the drag force and terminal speed. So in this case, you know that whenever there is a fluid in a there is a motion in a fluid. What is a fluid? Gas and liquid. So when we are moving in air, we do experience an opposition force, right? When we are moving in water, we do experience a opposition force. Now in everyday life when you are walking, it's negligible, right? You don't really think much about it. But if for example there is a very strong wind, you know that it becomes difficult to pass through that wind. It's even difficult sometimes to drive through that wind. And so it's always recommended that when the weather is windy, you should not try to go through it. Rather you should park your car or your bike or whatever and stay at a safe place until the wind is over. Don't try to overcome the wind, okay. So you know, you have heard also on this road sometimes the trees also break when there is a high wind. So we should not try to do that. Anyway, so this opposition force that a body experiences when it is passing through a fluid is called the drag force, and it is represented by the symbol capital D. Again, this is a kind of a force, okay. Now this drag force depends upon speed v, and it is given by D is equal to half C rho A V squared. Now in this case we know that C is the drag coefficient, just like the coefficient in the previous discussion that we had was mu, right? We had mu s and we had mu k. In this case it is called C and it is the drag coefficient, okay. Now what is rho? What is rho? The rho is a Greek letter that represents density. And density of what in this case? Density of the fluid through which the body is moving, okay. And what is the definition of density? Density is defined as mass per unit volume. So you divide the mass by the volume and you get the density, okay. So in this case, if the body is moving through air, it will be the density of air, and if it is moving through water, it will be the density of water. Now what is V? V in this case is velocity. What is A? A is called A is called cross sectional area. Very good. Okay, cross sectional area. Can you, Cheryl, define what is cross sectional area? Can you explain this? Why are we not just calling it area? Why cross sectional area? The surface that is perpendicular to your motion, it is that area, okay. Good. Right. Now we can also talk about the fact that this force, for example, if a body is falling through air, then this force will be balanced by the gravitational force, right. If a body is in a vertical motion, for a vertical motion, right, for a vertical fall, for example, we will have our motion, fall or motion, we will have d minus fg will be equal to ma, right. The example in this case is given of a skier. You know what a skier is? You know skiing. Skiing is a very interesting sport that happens on mountains where there is ice, right. So there is a slope, you know, when you are going down a slope, Again, that's a different kind of a motion, you have to control yourself. Also, when there is ice, it is very slippery, and then you wear skis and then it becomes a sport, right. It is very interesting, but then it can be dangerous as well. And so, you have to keep in mind all these things, and this is like when you are walking, you do not really experience much of a drag force, but when you are skiing, you experience a lot of a drag force, right. And then you have to understand for example, there is a picture in your book as well, there are different techniques to overcome this force, and one technique is known as the egg position. You will see that there are skiers who change the shape of their body in order to reduce the cross sectional area, because if you are decreasing the cross sectional area, the drag force decreases. So, you call it an egg position, where they try to fold their limbs and try to reduce this area. So, these are different techniques you use in sports, right. Okay. So, you know that if the body falls long enough, d eventually equals fg. This means that a is equal to 0 and the body's speed no longer increases. So, during the motion, there comes a stage when d becomes equal to fg, and if d becomes equal to fg, it means the acceleration becomes 0. It means the body starts moving with a constant velocity, and that constant speed is called terminal speed Vt. So, terminal speed is the constant speed that is achieved when d is equal to fg. So, this is called Vt, terminal speed. Okay. And in order to find the value for this terminal speed, we can put the values where the drag force and Ag become equal to each other in this equation, in the above equation, and we can calculate the value of Vt, which comes out to be 2fg over C rho A under the root. Is that clear? यहाँ पे when d becomes equal to fg, ठीक है, where it means d minus fg is equal to 0, right. So, you put the value of d from this equation and you can then find the value of Vt, which becomes this. So, this is the equation for the terminal speed. Also, this principle is very important in many kinds of sports that we will continue to study in the next class, right. So, for example, how a cat falls from a height, you know, it depends on the cat's position, how it can avoid getting injured. Also, how you skydive, that is also very interesting. Okay. So, you have to have an understanding of these principles in order to minimize the chances of injury and to have a safe landing, right. Also, parachuting, for example, you also use these principles there. Okay. ठहरो मैं वो साइड वाला मिटा दूँ, गाड़ी जो है गाड़ी वाला काम खत्म हो गया. You can switch this off.